Good. Last day of the unit right here. Last day, you guys know we're reviewing tomorrow, and the test will be on Thursday. Okay, test will be on Thursday. Look, sorry if you missed a day or two of this unit. Not my deal. You guys know I've got all the lessons posted, and you guys know when I'm available. So please don't make that an excuse why you may not do so hot on Thursday. All right, I'll be here for anybody that wants to come in and review. All right. Here's what we got to do today. We've taken these fractions, we've added them, we subtracted them, we've multiplied, we've divided, we've set them equal to another fraction and solved for x. Now we got to look at the graphs. Good news is I am not going to have you actually graph these, but I need you to know something about the graphs. So what I'm going to do first here is, well, we're going to go to a website right now. Instead of using your graph, we could use your graphing calculator. Sorry, that's where I did this graph here. We could use your graphing calculators, but I'd like a bigger screen to see it on. All right, so where we're going to live today to see some of these graphs, if you guys go to right now, type in your address bar, Desmos, DESMOS.com. And then click on the graphing calculator. It offers right there at the beginning. All right, right here, graphing calculator. And it should open up to what you see here, your grid. Okay, so let's start with this first one here we're going to graph together, which is 4 over x plus 4. So what you're going to do in your screen right now, you're going to y equals, ready? Y equals 4, hit your slash divided by sign, and take a look, everyone, on mine too. It should go right to a fraction bar. X plus shift equals plus 4. And everyone sees the graph. Hopefully it matches mine. Yep.
Well, my phone looks like mine. It's charged.
Okay, use your calculator then. Go to your y equals screen, get a fraction template, 4 over x plus 4.
There's no problem now.
Yep.
Do I use a Chromebook charger?
In the back there on the filing cabinet, there should be 3 of them there. Okay, everyone got the same graph that I have up here. Okay, you guys can pinch it, expand it, whatever you need to go a little bit bigger. All right, there's certain things I need you to find today on these graphs, okay, given the fraction. First one is, and this is going back to last year's, the domain. What's the domain here? All right, if you guys see on your graph, and I'll use mine here up on the board, that you go to end, ready? Let me take this point right here. This point right, first I should go over. Domain, anybody remember what domain was, x or y is?
Like all possible x values, right?
All, but I don't have any, there's one x value that's missing here. Okay, so this won't, it's the x values, yes. All right, these are the x values, so I'll just remind you, these are the x values. So do you see, pick a point somewhere on your graph on your screen right now. So if I take this point on my graph, this x coordinate right there is represented. If I take this point, this x coordinate's represented. Does anybody see a point on the x-axis where there is no graph when I look above and below it? Because there is. Take a look carefully. There is a point on here, and where I go on the x-axis, I look above or below, and there is no graph. Take a look on your screen. It's there somewhere. And you can move it up and down too if you want to see more of the graph. That's why I like going to this website. Like if I go to 2, is there a graph at 2? Yeah, right here, right above it. If I go to -6, there's a part of the graph is right below it. Anybody see the number where there is no graph at all? Frank? Everyone look, -4. Do you see any graph at -4 at all? Me neither. So our domain's going to be everything except what x value? -4. Now, how do I write that? Because I want to make sure we can write it correctly in correct math notation. So D for your domain equals, and you guys can have parentheses, brackets. I use these, which are called braces, but I don't care what you have. Do brackets or parentheses. Tell me if you remember this from last year or not. X, because it's the domain. Do you remember this, such that? A little bit? Okay, that's how I want you to write it. X such that. Now, how do I write it's everything except -4? You just tell me x cannot equal which number? -4. There you go. There's your domain. Everything but -4. That's what that's saying. x such that x can't equal negative 4. All right, let's go y values now. Y values, range. Okay, those are my y values. Anybody's now take a look at the y values. Let's take a look on my graph here. Let's see, if I go to 2 on the y-axis, do I have a graph to the left or to the right? Yeah, I do, okay. 4 I do, negative 2 I do, 1 I do. Is there a spot here where I don't? Because there is. Mike? 0. Look, guys, hey, everyone look at 0. Do you see any graph to the right or to the left of 0? No, I don't. So it's all y values except for 0. Everyone see that on your graph? All right, I have anytime I go to the y-axis and look to the left or the right, there's a graph, except for when I go to 0, there's no graph. So how do I write this now? Very similar to the domain. R equals, what variable am I going to put in now? Y, because it's the range, such that y cannot equal 0. All right, so we got domain range. I'm also going to ask you for the Y-intercept now. Anybody remember what the Y-intercept was?
Oh, I know.
Jeremy?
The Y.
No, just not here, just in general.
Is where it touches the Y.
Where the graph crosses the y-axis. Where does it cross the y-axis?
1.
At 1, correct. So what we're going to say is the y-intercept is 0, 1. Everyone see it? 0, 1 right here. There's my y-intercept where it crosses. All right, probably some new terms here. New terms. Vertical asymptote. Probably never heard of that word before, asymptote. Okay. First of all, vertical meaning up and down, right? Up and down. What I'm looking for is a line right now that you can draw, a vertical line that you can draw in here that will not touch either graph. It might come very, very, very close to touching, but will not touch the graph at all. A vertical line that we could draw in right now on your screen that would not touch the graph at all. That is a asymptote. Does not touch the graph at all. Anybody see the line I could draw? And it should have some relationship to something else we just solved. Yes, Claire? Look, let me draw it in. 1, 2, 3, 4. Comes awfully close, but the graph will never touch that. Does everyone see that? So here's how we write the vertical asymptote. And you guys may remember this from your graphing lines days. X equals negative 4. That's the equation of a vertical line. X equals. What do you notice here? You're starting to notice a relationship between the vertical asymptote and the domain. Yes, that'll always happen. That'll always happen. Horizontal asymptote, same thing. Can you draw a horizontal line in that will not touch your graph, but come very, very close? And where is it? 0, yep. Right here. Here's your horizontal asymptote. Also has a relationship with the range. So it's going to be y equals 0 is your horizontal asymptote. Vertical is always x equals. Horizontal is always y equals. Anything you want to ask? Because those are the 5 things I'm going to be asking for today. But it's going to get tougher. Yes?
The say the vertical asymptote and the domain always the same.
Correct. Yep. And there's even more of a relation because in a couple, I'll talk about it then. We'll just stick here for now. Everyone good? Okay, let's do one more. So go back to your Desmo screen right now. You can backspace. Okay, this next one though, you just got to be careful because there's more than a 4 in the numerator. It's a 2x plus 1, so you got to put it in parentheses. Okay, so put it in parentheses. So ready? 2x. Let's go. Plus 1. Put it in parentheses. Divided by slash x minus 3. All right, everyone see your graph? Again, you can move it around if you need to see more of it. Okay, let's talk domain. Domain. Go to an X value. Is there a graph above or below it? Start looking at numbers now. So if I go to 8, yep, there's a point at 8. So 8's part of it. 6 is part of it. 0 is part of it because I got a graph right here. -4 is part of it. Anybody see any point I could go to where there's not a graph above or below?
3.
Mike?
3.
Everyone look at 3. Halfway in between 2 and 4. Look right here. 3. I don't. It comes awfully close, but it's never going to get to 3. Everyone see that? Okay, so let's write it. X or D equals domain equals X such that X cannot equal 3. How about the range? You guys find a vertical up and down where it never hits. So if you go to your y-axis now, y-axis, where there's no graph to the left or to the right here. Anybody see it? Mike, going to stick with the range. What do you got?
2.
Everyone look at 2. Everyone 2. Look it to the right or left. I don't see a graph at 2, and you guys can see it even better. You got a better screen than I do. So the range is y such that y cannot equal 2. All right, now we get a little bit more tricky, right? We get a little trickier because y-intercept, it's not as clear as the last graph. Okay, the y-intercept is not as clear, right? I'm not going to guess either. Maybe it's -1/2. Maybe it's -1/3. I'm not guessing. Okay, I'm not guessing what that point is. So how do I if I can't tell by the graph, how can I figure out where it crosses the y-axis? You're going to do it algebraically. Jeremy?
I'm probably gonna have to zoom in and see the-
Okay, but I'm not going to I'm not going to allow you to use that on the test. So you're going to have to figure out a different way. All right? What's that?
You can use a calculator.
You could. All right, I'm going to go, I want to go quick though. All right, instead of pressing, remember to press this button, this button, this button. Y-intercept is when the x equals 0. Right? Your y-intercept is whenever the x equals 0. So every time you see an x, I'm going to have you plug in 0. Ready? 2 times 0 plus 1 divided by 0 minus 3. The y-intercept is wherever x equals 0. And now figure out what it is. 2 times 0 plus 1 over 0 minus 3.
-1 there.
You get 1 on top, -3 on the bottom. So my y-intercept, ready? 0, -1/3. All right, it wasn't -1/2, it was -1/3. Okay, vertical asymptote. Where's the vertical line? X equals, got it. Okay, I'm never going to accept this. It's got to be an equation. X equals 3. And again, I can just look back at my domain. The domain will tell me what the asymptote should be. And what about horizontal? Y equals 2. Questions, comments? Okay, close the Chromebooks. Turn the calculators off. We're going to do this without even looking at the graph now. Because we can. Ready? Okay, how the heck do I do these problems without even looking at the graph? Okay, all I want for this one here is horizontal, vertical asymptotes, the y-intercept. That's it. Okay, no range, no domain yet. All right, ready? Okay, let's start with the vertical asymptote because that's the easiest. All right, how do I find the vertical asymptote? I'm just going to abbreviate it VA if everyone's all right with that. How am I going to figure out where that vertical line is if I don't have a calculator in front of my face or a graph? can you please go back and look at the last two problems that we did? So flip your notes back over, because I don't want to tell you this. I want you guys to figure it out for yourself. Here's what I want you to look at. What our vertical asymptote was and the equation of the graph. I got x equals 3, and that was the equation of the graph. There's something powerful with that 3 as far as your equation goes. First problem, I got -4. Here was the equation I graphed, 4 over x plus 4. Something's going on there. And I know most of you can read it in your notes. So Jeremy, go ahead. You can read it in your notes.
So you have to ensure that the denominator is equal to 0.
Okay, ready? Your vertical asymptote is what makes this undefined. Remember undefined, you get what in the denominator? Okay, so you find the vertical asymptote without using this by figuring out what value of x is going to make it undefined. So go back to one we're working on. What's in the denominator right now? X minus 2. So what value of x could I plug in that makes it undefined? 2. Everyone agrees? There's your vertical asymptote. Whatever makes the fraction undefined. X equals 2. We all good there? That's the vertical's the easy. Horizontal's the challenging one. So that's where there's going to be no graph at x equals 2, a vertical line. All right, let's go to horizontal now. This is going to be a little bit more of a challenge for us because there's some rules we need to follow. The rules are all up here for you. Okay, the rules are all up here under number 2. All right, let me first talk about the degree. What's it mean by the degree? The degree is the highest exponent in the numerator and the highest exponent in the denominator. That's what degree means. Okay, that's what degree means. So let's look at this first fraction in number 3. And what's in the numerator? -4. Is there any variable there?
No.
Okay, so we say the degree is 0. Okay, if there's no variable there, the degree is 0. What's in the denominator? X minus 2. What's the highest exponent there? What's the highest exponent in the denominator? X minus 2. There's only one exponent there. What is it? 1, right? Right here with the x to the first. So in the numerator, I had a degree of 0. In the denominator, I had a degree of, what was the highest exponent? 1. Everyone good there on what I mean by degree? Yes, no, maybe? We're going to do a couple more, and I'm going to call on you here. So what had the higher degree? Numerator or denominator? Denominator. So let's look at our rules right now. If the degree of the numerator is greater than the degree of the denominator, was that true? Is that true? Nope. All right. Degree of the numerator is less than the degree of the denominator. Is that what I have right now? Yes. 0 and 1. What happens? The horizontal asymptote is always the line y equals 0. Okay? Y equals 0. Real quick, go back to problem number 1. Go back to problem number 1. Take a quick look at it. Remember, we found out looking at the graph, it was y equals 0. Well, why? What was the degree in the numerator? It's 4. What's the degree? 0. And what was the degree in the denominator? X plus 1 plus 4. 1. So if the denominator is greater, it's always y equals 0. And there's one more thing we need to find, Y-intercept. How do we find that algebraically? We made x equal to 0 and solve, right? So we take our fraction, -4 over everywhere I see an x, I plug in 0 minus 2. And that'll give you the y-intercept. And it ends up being -4 over -2, which is 2. So it crosses the y-axis at 2. I'd appreciate it, though, if you wrote it 0, 2, to show that it's a point on the y-axis, 0, 2.
Will you take off points if we don't?
Probably not. I'll be just happy that you got 2. All right, ready? We got 2 more here, and now I'm going to start calling on people. Okay, next one, 4x plus 2 over x minus 1 without using a calculator or your Chromebook. Vertical asymptote. Where would this be undefined? Where would this one be undefined? Maybe one more. 17. Sarah, where's this undefined? At 1. I don't. Hey, I will not give you credit for this though. You just write 1. X equals 1 because I'm looking for an asymptote is a line, so I need the equation of a line. X equals 1. All right. Let me work with you on the horizontal asymptote now. Now we got to follow these rules. So I'm looking for the degree in the numerator and the denominator. Here we go. A little help from you guys. 21. Wish we had one. Okay, Jeremy, what's the highest exponent in the numerator?
4.
4 is not an exponent. Exponents are the ones above the x here. So what's the highest exponent? 1. And what's the highest exponent on the bottom?
1.
Okay, so does everyone see they're the same? 1 on top, 1 on the bottom. So go back, ready? Go back, reread your rules. This is letter C. If the numerator and denominator are equal in degree, ready? Here's the horizontal asymptote. It's the numbers out in front divided by each other. So ready, Jeremy? Go back. What's the number out in front in the numerator? What is it? 4. And what's the number out in front in the denominator? 1. 4 divided by 1? 4. Okay, so it's going to be equal to, anytime the degrees are the same, I take the numbers out in front, the leading coefficients they're called, numbers out in front, and I divide. That's the only time I do that, when the exponents are the same. Highest exponents are the same. And you're ready for the Y-intercept now. We'll get one. Oriana, how do I find the Y-intercept again? What do I need to plug in?
You plug in 0 for X.
Correct. Everywhere I see an X in that fraction, I'm going to plug in 0. And when you get that value, Oriana, let me know.
Is there like an error?
What do you plug it in your calculator?
Every time 0 plus 2 divided by 0.
Are you putting in a fraction or are you just using the division symbol there?
Oh, I put negative 1, sorry. Two.
Positive or negative?
Positive.
You get 2 on top, right? And then you should get a negative 1 on the bottom,
Yeah.
right? So it should be negative 2 for your Y-intercept. 0, comma, negative 2. Okay, you guys are on your own for this one. 5, go ahead. 5 on your own. Find all 3 for me on your own. Actually, let me do the vertical. Now that I look at this, I should do the vertical asymptote with you. What makes it undefined? Ooh, that's a tough one, right? Because you got a squared there. You want to, well, that's the thing though. You're only half right. You want to know when the denominator equals what?
0.
Okay, ready? Go. x squared minus 1. This is what we did during our first day of undefined fractions. When is that equal to 0? What do you want to keep going? Come on, keep going. You got this. X squared minus 1.
X plus 1, X minus
Fact difference of two perfect squares. X plus 1, X minus 1. So you're just not going to have one asymptote.
and then you reject the X plus 1 because then it will turn out to negative 1.
But that's what I'm looking for.
Yeah.
Why would I reject it?
Because,
I'm looking for when it makes it undefined, Jeremy.
yeah, because if you
I'm not Jeremy, I'm not looking for this isn't problems from yesterday. I'm not looking for a solution. Okay? I'm looking for where am I going to get a vertical asymptote? I'm going to get one at x equals negative 1, and I'm going to get one at x equals positive 1. These aren't solutions, right? These aren't equations I'm solving, Jeremy. This is just where I'm going to get a vertical asymptote on my graph at negative 1 and 1. So I'm not going to reject anything. All right? Go ahead. Horizontal asymptote and Y-intercept for me, please. Go ahead. You guys can try that on your own. Go back, look at your rules if all your rules are right on top, so we don't need to go back. Read your rules.
These rules beyond the test, or should you just memorize them?
I'm not giving them to you.
Okay.
Come on, you're in big boy math now.
That works.
All right? You are in big boy math. And probably there might be one, maybe two of these questions on the quiz test. All right, how'd the horizontal asymptote go? You looked at the degrees, you figured out where it was bigger. What did the rule say? What asymptote do I have for horizontal? Jeremy?
no horizontal.
Correct, none. Here's why, everybody. The degree was 4 in the numerator, 2 in the denominator, and if you go back and read your rules, if the degree of the numerator is greater than the denominator, no horizontal asymptote. Good, Jeremy? Yep.
Y equals 0 work?
No, y equals 0 is an asymptote, going through 0. None means none exists at all. Okay, if you say y equals 0, there is one that exists. Y-intercept, what do we end up with y-intercept algebraically? Elizabeth, what'd you have?
I said 0, 2.
0, 2, good. She did 0 to the 4th minus 2 over 0 squared minus 1, which gives you 2. 0, 2, great job. That's where it goes through. Okay, any issues? All right, one little sneaky, challenging one here to end it, and then you're going right to the book. Notice what did I add in here to this fraction? Yeah, we haven't had this, right? All we've had was so far is the fraction, and that's it. Now I threw this little minus 8 here. Minus 8. You guys didn't remember anything from your math days here? What the negative 8 does to the graph? Well, it's going to change. What's happening to this graph right here? Come on, there we go. This graph right here, something's happening to it when I subtract 8. Anybody know where it's moving? Down 8 units. All right, down 8 units. So you guys can see here on my screen, everyone see the red graph? That's 3 over x minus 7 is the red graph. The blue one is minus 8. See how it went down 8? Okay, so that's going to affect a couple things here. All right, that's going to affect a few things. Let me start with vertical asymptote. I'm going to go out of order a little bit. Let's start with the vertical asymptote. Going down does not change it because it's not going to change a vertical line. Going down 8. So just use our rules. What should the vertical asymptote be? Look at the fraction. Remember, it's what makes the fraction undefined. 20, Sarah. What's going to make the fraction undefined? 7. So vertical asymptote, not just 7, but what have we been writing? X equals 7. Okay, moving it down is not going to affect that because remember, vertical line is here. That's not going to affect it. All right, while we're here, why don't we just do domain because they're related to each other. Okay, let's do the domain. Making sure we are solid on this relationship between domain and vertical asymptote. So the domain is going to be x, right, because it's x value, such that, what are you going to tell me? X cannot be equal to what? 7, because I don't have a graph there. That's why the asymptote is there instead. Okay, we all good? Okay, now let's go horizontal, because this will change things now. Horizontal asymptote. Okay, let's forget the -8. What's the degree in the numerator?
0.
Everyone agree it's a 3, so that means it's 0. What's the degree in the denominator? 1. So according to my rules, what should be the horizontal asymptote if the degree is bigger in the denominator? Go back to your rules. Should be y equals 0, right? Should be, right? I should be writing y equals 0, right? This horizontal line, y equals 0. But what's happening to the graph? It's going down 8. So is the horizontal asymptote. So instead of y equals 0, it's going to be y equals -8. It only affects the horizontal asymptote. What's your range then? Let's keep going. What's your range? Y, so R equals y such that, what can't y equal here? -8. Yep, cannot equal -8. They go together, the range and horizontal. And then Y-intercept, what are you still doing? Plug x equals 0 in. Done. Doesn't matter. Excuse me. Doesn't matter that I'm moving it down. You get a crazy fraction probably in your calculator. Good thing we got fraction templates and everything can handle that.
-9/7.
Yep. That's what I have as a fraction anyway. Some of you guys may have the decimal version. -59/7. So my y-intercept 0, comma, -59/7. Okay, vertical domain go together. Horizontal asymptote range go together. Y-intercept, plug in 0 for x. That's all you're doing. Look at the directions, please. I do not want you to graph any of them. All you're going to do is find domain, range, everything we just found today. All right, don't graph them. All right, if you want to use Desmos or your graphing calculator to help you as well, that's fine. All right, you'll have your graphing calculator for the test, but not Desmos. All right, let's go. Open it up. Let's get going. Get through a couple problems. You guys know where the answer key is.